Bismillahirrahmanirrahim. Rabbi zidni ilma. Quote of the day. There is only one thing that makes a dream impossible to achieve. The fear of failure. Assalamu alaikum. My name is Dr. Sadia Rafiq and today my topic of presentation is Inferential Statistics Part 1. Learning outline includes overview of the inferential statistics, including confidence interval, hypothesis testing, statistical test, standard error of mean. At the end of my presentation, my colleagues will be able to describe inferential statistics, confidence interval, hypothesis testing, statistical testers, and standard error of mean. Statistics is a branch of applied mathematics that deals with the collection, organization, presentation, analysis, and interpretation of data. Basically, it has two types, descriptive and inferential. Descriptive statistics are numbers that are used to summarize and describe data. The word data refers to the information that has been collected from an experiment, a survey, a historical record, etc. Inferential statistics include the sample as a set of data taken from the population to represent the population. Probability distributions, hypothesis testing, correlations, testing, and regression analysis all fall under the category of inferential statistics. What is inferential statistics? It is a technique used to draw conclusion about a population by testing the data taken from the sample of that population. It is the process how generalization from sample to population can be made. It is assumed that the characteristic of a sample is similar to the population's characteristics. It includes testing hypotheses and deriving estimates. It focuses on making statements about the population. The process of inferential analysis includes raw data. It comprises of all the data collected from the sample. Depending upon the sample size, this data can be large or small set of measurements. Then comes the sample statistics. It summarizes the raw data gathered from the sample of the population, and these include the descriptive statistics, so includes a measure of central tendency, measures of dispersion, measures of position. Then moving towards the inferential statistics. These are generated to generate conclusions about the populations made upon the sample statistics. Sampling methods. Random sampling is the best method of sampling methods to use the inferential statistics. It is also referred to as probability sampling. In this method, each participant has an equal probability of being selected in the sample. In case the population is small enough, then everyone can be used as a participant. Important definitions. Probability. It is the mathematical possibility that a certain event will take place. They can range from 0 to 1. The parameters describe the characteristics of a sample of a population, including the variables such as age, gender, income, etc. Statistics describe the characteristics of a sample on the same type of variable. Sampling distribution is used to make inferences based on the assumption of random sampling. Sampling error. Inferential statistics takes sampling error, random error into account. It is the degree to which sample differs on the key variable from the population. Confidence level. The number of times out of 100 that the true value will fall within the confidence interval is called the confidence level. And what is the confidence interval? A calculated range for the true value based on the relative sizes of the sample and the population. Sampling error describes the difference between sample statistics and population parameters. The variables of the sample taken from the population should be the same from the population also. Due to sampling error, the sample mean can be varied. And the amount of this variation in the sample mean is referred to as standard error. And standard error decreases as the sample size increases. Types of hypothesis. Alternative hypothesis. It specifies expected relationship between two or more variables. It may be symbolized by H1 or HA. Null hypothesis. It is a statement that says there is no real relationship between the variables described in the alternative hypothesis. In inferential statistics, the hypothesis that is actually tested is the null hypothesis. Therefore, it is essential to prove that the null hypothesis is not valid and alternative hypothesis is true and should be accepted. So starting different steps, first state the research hypothesis, then state the null hypothesis, then next comes to choose a level of statistical significance, then we move towards the select and compute the test statistics, and then make a decision regarding whether to accept or reject the null hypothesis. Now we discuss one by one the further. First comes in confidence intervals. A confidence interval is a region extending both above and below sample statistics, such as sample mean within a population parameter, such as a population mean, may be said to fall with a specified probability of being wrong. That is called confidence interval. Sample measure statistics are used to estimate population measures. These statistics are called estimators. And the sample mean is a better estimate of the population mean than the sample median or sample mode. A good estimator should satisfy these three properties which are given below. One, the estimator should be an unbiased estimator. That is, the expected value or the mean of the estimates obtained from the sample of the given size is equal to the parameter being estimated. Next, it should be consistent. The consistent estimator, as sample size increases, the value of estimator approaches the value of the parameter estimated. And the third is the estimator should be relatively efficient estimator. That is, of all the statistics that can be used to estimate a parameter, the relatively efficient estimator has the smallest variance. So these are the three properties of the good estimator. Now, there are two types, point estimate and interval estimate. The point estimate is a specific numerical value estimate of a parameter. The best point estimate of the population mean is sample mean X bar. The interval estimate of the parameter is an interval or a range of values used to estimate the parameter. The estimate may or may not contain the value of parameter being estimated. The confidence level of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter, assuming that a large number of samples are selected and that the estimation process on the same parameter is repeated. The confidence interval is a specific interval estimate of a parameter determined by using data obtained from a sample and by using the specific confidence level of the estimate. Hypothesis testing. Statistical hypothesis testing is a way of determining the probability that an obtained sample statistics will occur, given a hypothetical population parameter. A researcher hypothesis specifies the nature of the relationship the researcher thinks exists in the population. The null hypothesis typically specifies that there is no relationship in the population. The three methods used to test hypothesis are: one, the traditional method; second, the p-value method; and third is the confidence interval method. Steps in hypothesis testing, traditional method. Every hypothesis testing situation begins with the statement of the hypothesis. The statistical hypothesis is a conjecture about the population parameter. This conjecture may or may not be true. There are two types of statistical hypothesis for each situation, the null and alternative hypothesis. The null hypothesis, symbolized by H0, is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or that there is no difference between two parameters. The alternative hypothesis, symbolized by H1, is a statistical hypothesis that states that the existence of a difference between a parameter and a specific value, or states that there is a difference between two parameters. A statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. The numerical value obtained from a statistical test is called a test value. These are the possible outcomes of the hypothesis test. It is drawn by in a 2 by 2 table, contingency table is showing. First, we have the option the null hypothesis is true and null hypothesis is false. And when we reject the null hypothesis and we do not reject the null hypothesis. These are the columns A, B, and C, D. A is the column when we did the error. How? The null hypothesis was true. There was no relationship, no association between variables, but we reject that hypothesis. So we committed the error type 1. In the column B, the hypothesis was false and we also rejected. So it was a correct decision. In the next C column, the null hypothesis was true and we do not reject it. So we accept this output. This was our correct decision. And the last, the null hypothesis was false and do not reject. We do not, it is again, there is an error which is called type 2 error. So type 1 is error is falsely rejected of the null hypothesis. And type 2 in short form is the falsely accepted the null hypothesis. So type 1 error occurs if you reject the null hypothesis when it is true. And type 2 error occurs if you do not reject the null hypothesis when it is false. The level of significance is the maximum probability of committing a type 1 error. This probability is symbolized by Greek letter alpha. The critical value separates the critical region from the non-critical region. The symbol of critical value is CV. The critical or rejection region is the range of values of the test value that indicates that there is significant difference and the null hypothesis should be rejected. The non-critical or non-rejection region is the range of the values of the test value that indicates the difference was probably due to chance and that the null hypothesis should not be rejected. So you can see in this Gaussian curve, normal distribution curve, this is the non-critical region. Non-critical region means non-rejection region. And this is called the critical region, which means the rejection region. In a two-tailed test, the null hypothesis should be rejected when the test value is in either of the true critical regions. When the test value will fall in the critical region, then we will reject the null hypothesis. This area is the acceptance region, is a non-rejection region. Next comes the solving hypothesis testing p-value method. In these have 5 steps. Number 1, state the hypothesis and identify the claim. Compute the test value, find the p-value, make the decision and summarize the results. Next come the significance levels. The term significance levels or level of significance are used in research, refers to the probability of a sample statistics occurring as a result of sampling error. The significance level most commonly used in educational research are 0.05 and 0.01 levels. The statistical significance and practical significance are not necessarily the same. Even if a result is statistically significant, it may not be practically significant. Test of statistical significance. A one-tailed test of significance involves the use of probabilities based on one half of the sampling distribution because the research hypothesis is a directional hypothesis. A two-tailed test, on the other hand, involves the use of probabilities based on both sides of sampling distribution because the research hypothesis is a non-directional hypothesis. Parametric tests for quantitative data. A parametric statistical test requires various kinds of assumptions about the nature of the population from which samples involved in the research study were taken. Some of the commonly used parametric techniques for analyzing quantitative data include the t-test for me, ANOVA, ANCOVA, MANOVA, MANCOV, and t-test for R. Parametric test for categorical data. The most common for analyzing is a t-test for difference in proportions. Non-parametric test for quantitative data. A non-parametric statistical techniques make few, if any, assumptions about the nature of the population from which samples of the study were taken. Some of the commonly used non-parametric techniques for analyzing quantitative data are the Mann-Whitney test, the Truska-Wallace one-way analysis of variance, the sign test, and the Friedman two-way analysis of variance. Non-parametric test for categorical data. The chi-square test is a non-parametric technique most commonly used to analyze categorical data. The contingency coefficient is a descriptive statistics indicating the degree of relationship between two categoric variables. Power of a statistical test. The power of a statistical test for a particular set of data is the likelihood of identifying a difference when in fact it exists between population parameters. Parameter tests are generally, but not always, more powerful than non-parametric tests. These are the common tests of significance, and you could say the type of the variable qualitative or quantitative, sample size large, then the group compared to or more than two, test of choice is Z test difference in two proportions and chi-squares, and test statistics. And when it is small, two or more chi-square coefficient exact test. In the case of quantitative data, it is large, then Z test difference in two means, and it is small, than T test, and the ANOVA is used. I will describe Z test and T test in my next presentation. Now moving towards the standard error. If we take a random sample from the population and similar samples over and over again, we will find that every sample will have different mean. If we make a frequency distribution of all the sample means drawn from the same population, we will find that the distribution of the mean is nearly a normal distribution, and the mean of the sample means practically the same as the population mean. This is a very important observation, that the sample means are distributed normally about the population mean. The standard deviations of the means is a measure of sample error and is given by the formula sigma over square root n, which is called the standard error or the standard error of mean. 95% confidence interval of the mean. The standard error of mean is used to describe a 95% confidence interval for an observed mean. 95% confidence mean plus minus 2 standard error of mean. This confidence interval narrows with large sample size. So we have the formula standard error is equal to standard deviation divided by square root of n sample size. Confident that 95% of all sample means based on the given sample size will fall within the range of confidence interval. It is the interpretation of estimates with confidence intervals. Now talking about the distribution of sample means. A sampling distribution of means is a frequency distribution resulting from plotting the means of very large number of the samples from the same population. The standard error of the mean is the standard deviation of the sampling distribution of the means. The standard error of the difference between means is the standard deviation of the sampling distribution of difference between sample means. More elaboration of the same concept. Distribution of the sample means. For example, suppose a researcher selects a sample of 30 adult males and finds the means of the measure of the triglyceride levels for the same subject to be 187 milligram per deciliter. Then suppose a second sample is selected and the mean of the sample is 192. Continue the process for 100 samples. What happens that there is become a random variable and the samples will be 187, 192, 184 and so forth. Substitute a sampling distribution of a sample means. Now, a sampling distribution of the sample mean is a distribution using the means computed from all possible random samples of the specific size taken from the population. If the samples are randomly selected with replacement, the sample means from the most part will be somewhat different from the population mean. These differences are caused by the sampling error. And the sampling error is a difference between the sample measures and the corresponding population measures due to the fact that the sample is not a perfect representation of the population. When all possible samples of the specific size are selected with replacement from the population, the distribution of the sample means for a variable has two important properties, which are explained. Properties of the distribution sample means. Number one, the mean of sample means will be same as of the population mean. So the mean of the sample means, which are multiple sample means, which are taking from the population, the mean of those sample means will be the same of the population mean. The standard deviation of the sample means will be smaller than the standard deviation of the population. And it will be equal to the population standard deviation divided by the square root of the sample size. The following example illustrates these two properties. Suppose a professor gave an 8-point quiz to a small class of 4 students. The results of the quiz were 2, 6, 4, and 8. For the sake of discussion, assume that the 4 students constitute the population. The mean of the population is, like as we all know, mean is number of observation divided by total. This comes 5. The standard deviation by applying the formula square root of all the values is this 5 and standard deviation this. The graph of original distribution shown in this is called a uniform distribution. I'll show you. This is the graph, the frequency and the score. Now, if all the sample size of 2 are taken with replacement and the mean of each sample found, the distribution is shown. This is the sample and we have taken the mean. Now we define the frequency distribution of the sample means. Okay, so this is the mean, and now we will find out the frequency distribution. 2 comes 1 time, 3 comes 2 times, and 4 comes 3 times. From the data, from the example, this figure shows the graph of the sample means. The histogram appears to be approximately normal. The mean of the sample mean is denoted by mu x bar is this. We added all these mean divided by summation of this, and it comes 5. 80 divided by this comes 5, which is same as the population means. So the standard deviation of the sample mean is denoted by sigma over x bar, same by putting the values and divide, it comes this, which is the same as the population standard deviation. I show you. Initially, when we have this, mean of the population was 5 and it was 2.236, and by calculation we find out it was 5, the mean of the sample means, and it is 1 point same. In summary, if all possible sizes of samples of size are taken with replacement from the same population, the means of the sample mean is denoted by mu x bar equals the population mean, and the standard deviation of the sample mean denoted by sigma x bar equals to sigma divided by square root of n. The standard deviation of the sample mean is called the standard error of the mean. Hence, it has the formula sigma x bar standard deviation over n. A third property of the sampling distribution of sample means pertains to the shape of the distribution and is explained by the central limit theorem. Central limit theorem, as the sample size n increases without limit, the shape of the distribution of the sample means taken with replacement from a population with mean this and standard deviation sigma will approach a normal distribution. As previously shown, this distribution will have a mean mu and the standard deviation mu over n square root n. If the sample size is sufficiently large, the central limit theorem can be used to answer questions about sample means in the same manner that a normal distribution can be used to answer questions about individual values. The only difference is that the new formula must be used for z values, and it is this. Z is equal to sample mean minus population mean sigma divided by square root of the n, where x is the sample mean and denominator must be adjusted since means are being used instead of individual data values. The denominator and the standard deviation of the sample means. So it is important to remember two things when use the central limit theorem. When the original variables normally distributed, the distribution of the sample mean will be normally distributed from any sample size n. When the distribution of original variable might not be normal or sample size of 30 or more is needed to use a normal distribution to approximate the distribution of the sample mean. The larger the sample, the better the approximation will be. As you can see this normal distribution curve, and we will divide in the z-score, and then we have divided the formula 1 plus 2 standard deviation mu. This will show how the standard normal distribution can be used to answer questions with about sample means. Thank you so much. These are my references. And now moving towards the multiple choice questions. Number 1, if a relationship between two variables is called statistically significant, it means the investigator thinks the variables are related in the population represented by the sample, not related in the population represented by the sample, related in the sample due to chance alone, or it's very important.
B.
Alpha.
Read it. No.
C.
The correct answer is A. I have said if a relationship between two variables is called statistically significant, it means the investigator think the variables are related in the population represented by the sample. It means we always generalize inferential study the results of the sample to the population. So if it is significant, we think it is related to the population. So the option A is correct. Given IQ scores are approximately normally distributed with a mean of 100 and standard deviation 15, the proportion of people with IQs above 130 is. So you have to think over it, do mental maths, or if you have a pen, do it. Mean is 100, standard deviation is 15. The proportion of people with IQs above 130 is 95%, 68%, 5%, and 2.5%.
95%.
68%.
90.
No.
95%.
No. So just do mental math and make a curve in your mind. I said mean is 100 and standard deviation is 15. Okay. So on standard deviation 1, it would be 115. On SD2, it would be 130. Okay. And I'm saying if the I-score are normally distributed above 130, I'm talking about IQ level above 30. So it is 2.5%. Got it? I'm talking about the percentage over above 130. At ST to ST, it would be 130. I'm talking about above 130. Next question. Failing to reject the null hypothesis when it is false is alpha error, type 1 error, beta, or type 2 error? Yes. Type 2 error. The histogram above presents the lifespan of a random sample of particular type of insect. Determine the relationship between the mean and median. Mean is equal to median, not equal to, lesser than, or greater than.
D.
Sorry?
C.
No, the answer is D. Mean is greater than median. As we can say, what is this is showing? Right side is skewness or positive skewness. The positive skewness, the median is in the middle, and we can see the days 0 to the days on axis, of frequencies on the y-axis. So mean is at the right side of the median. So it is greater than the median. The correct answer is D. If you draw all possible samples from some population, calculated the mean for each of the samples, and construct a line graph showing the shape of the distribution. Based on all those means, what would you have? A population distribution, a sample distribution, a sampling distribution, or parameter distribution?
Sample distribution.
Sampling.
Yes. C is the sampling distribution. We have taken multiple samples and we are drawing the line of those samples. So it is called sampling distribution. What is the standard deviation of the sampling distribution called? Sampling error, sample error, standard error, simple error.
Standard error.
Yes. It's called, because the standard deviation of the sampling distribution is called the standard error. Which of the following is the researcher usually interested in supporting when he or she is engaging in hypothesis testing? The alternative hypothesis, the null hypothesis, both the alternative and null hypothesis, neither the alternative or not.
Alternative hypothesis. Alpha.
Alpha.
Yes, alternative hypothesis. The researcher is always saying that there is a difference between the variables. So they're interested in alternative hypothesis. Which dash percent confidence interval will be the widest, or you can say the least precise, for a particular data set that includes exactly 500 cases? 99%, 95, 90, none of the above.
95%.
90%.
99%. Perfect percent is confidence interval will be the widest. Sabse bada, the widest one. So it is a 99% is the least precise. The correct answer is A. Assuming innocence until proven guilty. A type 1 error occurs when an innocent person is found guilty. True or false?
False.
No. It was a type 1 error. The person was innocent, it was found guilty. So it was a type 1 error which was committed. It is true. A box of 8 marbles has 4 red, 2 green and 2 blue marbles. If you select one marble, what is the probability that is the red or blue marble? Mental maths. 0.60%, 0.756 and 0.80%.
0.75.
Excellent. Yes, it's the correct answer. We will add, we have said about the red and blue marbles. We have 4 reds and blue. 4 plus 2 is 6 and divided by total 8, we get 0.75%. This is the key and thank you so much.